Okay, good morning, everyone. So, C7 guys here. I'll wait one more minute before we begin. You should see the first lab on Blackboard now under labs. So you can download that. You should download that. And actually, it's also the second lab. So lab 1 and lab 2 are in one single document. But when you turn in your lab reports, those need to be separate. So right now the link is up to turn in lab 1. And next week there will be a link for lab 2. So right now you just look at the lab 1 portion of it, of that document. No need to look at the second half. So you can just, copy those data tables and those questions to your lab report document, and write all those things like theory and procedure, and have those tables there as well. So you can just copy them from this document on Blackboard. Okay, today's lab will be pretty short. It's just a simulation, and theoretically it's not that complex. It's pretty beginner stuff. I'm sure you've already covered these topics in class like a couple of weeks ago. I think it will be the first week, I think. So since I think most of you have done physics 1, so you are basically in physics 1 you get familiar with mechanics and gravitation. So that's the force you're most familiar with till now. And we have 4 fundamental forces. Obviously we have gravitation, we have electromagnetic force, which is really what we discuss in physics 2, and then we have the strong and weak interactions, which usually are not discussed until higher level physics, because those are subnuclear forces. Their ranges are very small, unlike gravitation and electromagnetic force, where the ranges are infinite. So yeah, that's what we focus on, electromagnetic force. It is far stronger than gravitation. If you look, you might have heard of it like gravity. Gravity is the weakest force by far. A simple example of that would be, the gravity. So when you drop a pin onto the floor, you can have just a magnet, and have that magnet attract the pin. So it basically means that magnet, the electromagnetic force from that magnet, is counteracting against the gravity of the entire Earth. So I think the order of magnitude difference between gravity and electromagnetic force is around 40 orders of magnitude. So yeah, that very, very different in terms of strength. Okay, that was just some trivia. But let's look at the document. Okay, so I think, here you have lab section 2. So you don't need to look at this. We'll just look at lab section 1 today, which is electric field, potential, and Gauss's law as well. Okay, so it's pretty simple. Pretty sure all of you have done Coulomb's law, and it is, if you look at it, pretty similar to the law of gravitation. Here you have constant, a universal constant K. You had G for gravity, and instead of masses, now we have charges Q1 and Q2. So those are the 2 charges we have, and the distance between them is R. Again, that 1 over R squared, that inverse square dependence that we see in gravity, we have here as well. So it's a very similar equation that we have for the electrostatic force. So this is called Coulomb's law. And I don't think we really need to discuss this. This is pretty simple. So let us move on to what you have to do. And okay. So, okay. So you have this link here. I think right now I'm only sharing the Word file, and I'll need to stop this. And okay, when you, let me stop this and then I'll share my screen again. Let's wait on a sec. Also, by the way, I did post a YouTube link for videos, so you will see the introduction video there, and all those videos should be posted within 1 day. Sometimes it might take 2 days, but not more than that. So it should be there pretty soon. So keep looking at that if you're not able to attend the live sessions. So this is a simulation, but the next two labs I think are live stream labs. So it's probably a better idea to attend those. You can ask questions and there will be some questions there. All right. So when you click on that link that is present in the document, you will see something like this. Let me clear this bar. That, okay, so you see something like this. Now, better just to share the screen, isn't it? Okay. So if you go to the document, you have the equipotential sensor, voltage sensor. All right. So the charges have an absolute value of a nanocoulomb. So it's just you have been given the instructions here. Might be some grammatical errors. I didn't write this document, but if you have any issues, if you can't understand anything, just ask me. You can email me as well. So first you have to see how the electric field looks like. If you put a negative charge away, okay. So I think what it wants you to do. So you have a negative charge. You can put a negative charge in here. You can put a positive charge, and you can see the electric field lines. And it wants you to sketch different things, right? So you can remove one. So it basically wants you to do a sketch an electric field between two charges. So you get a positive charge, negative charge, whatever you see, and you try to answer if it makes sense. Now we will use only positive charge in this experiment. So again, do the same thing, whatever it says and whatever you see, type that down. To determine the relation between strength of the electric field and distance of a charge body away from the electric field, one positive charge was placed onto the grid. So you do that, then an electric field sensor horizontally aligned with a positive charge at varying distances. Okay, so different distances. Here you can see 0, 0.2 meters, 0.4 meters, and so on. I think what you can do here. So if this is the charge, what was it? Was it positive or negative charge? Positive. Okay, so you take a positive charge like this. You have these sensors. So to measure that distance, I think this would come in handy. 20 centimeters is 0.2 meters. So you can place it like this, calculate what your distance is. And you can stretch it to 40, 60 or whatever you want. So you can calculate that distance through this tape measure, the virtual tape measure. And this is a sensor, can give you the the value of the potential. And once you have that, so you get V. Now you need to know V over M. So you just divide by this distance. So so it's whatever potential you get divided by 0.2. and whatever potential you have divided by 0.4 at this distance. So you keep doing that. And then it says draw an Excel spreadsheet graph of viewer M versus distance. Answer these questions. Why does it look this way? Is there any equation you know that says that? Again, now you have to put another positive charge on top of. So you take two positive charges on top of each other, do the same thing. You have to stay one. Okay, now it's a constant distance 1 meter away from the positive charge, and you again do the same thing for total charge 1. So 2 charges over each other, 3 charges on top of each other, 4, 5, and so on. So you keep doing that and calculate these, and then again make an Excel graph. Again, answer these questions. So I think this is pretty simple stuff. Part B, you do the same thing, but now you create 2 parallel plates. Here you only use 3 charges. You're going to use more, use like 10. So you have 2 plates now, and you can sketch your electric field, what it looks like. Again, now you have 2 charged circles where the positive charge circle is completely covering the negative charge circle. Probably, as it says, you should try to create these circles better. So they have like 4 charges for the negative charge circle. You should draw a bigger circle, probably, and make sure there are no gaps. I don't know how it works in the simulation, but based on, we know Gauss's law. Gauss's law says that the electric flux through a closed surface should be equal to the charge contained within that surface. So try to use that logic here and see if it makes sense. If it doesn't make sense, try, that's why I say just try to cover it completely with those charges. Don't leave any gaps. That might be an issue in this simulation. So just try that. So yeah, they are trying to mimic this thing, but I don't know if the simulation can actually do it. But you know the theory, so you know what to expect. So if it's giving you something wrong, you could keep trying different things, and if it doesn't work, you just say, I expected this, but the simulation didn't work for me. And you need to post pictures of what you do. So when you draw these parallel plates, you need to post your picture of the parallel plates on your lab reports. Similarly, this and this, all the activities that are in this document, you need to take screenshots of those and post that on your lab report. Again, some questions these are all based on Gauss's law. You try to measure V as you change radial distance. So you have to use greatest distance. So you can keep changing the radius. Again, you have that tape measure there, so you can use it, keep changing. You also have to find the radius of the inner blue circle. I don't think this should be a problem. Semi-log plot. Okay, how many people know how to use Excel here? I hope it's pretty much everyone. Is there anyone who doesn't know how to use Excel? Okay, everyone knows how to use Excel to plot something. If you do, that's great. So I don't need to explain it, because that is pretty crucial here, because you need plots for this, and now this as well. And I hope you also know how to, well, I'll just make someone in chat. I'm not very experienced. Okay. Okay, let me do that. Do you have Excel open? No? Okay. So we'll open Excel, some column A, some column B, whatever. Actually, I don't need to write that. So enter some values. We'll have 2, 4, 6, 8, 10. And then some values here, 15, 45, 80, 140, 250. So let's say these are 2 set of values. select both, go to scatter, and this is the one that I like. It has the dots as well. So I just typed it in its number, so I thought I would get this kind of curve, some random numbers. Yeah, so okay, so you have this, and you can see the first column is your x-axis. You can also change this through just go to select data, and you can just switch between the axes. So you have this all now. Okay, let me. All right. How do I get that? Okay, yeah. So what it says in the document is to, if v is against log r. So v is not against r. So how do you do that? Logarithm of r. So you'll do here this. So when you want to convert an axis to a logarithmic axis, you will just take this off. And base, it says in the document, it should be base e. Here we have base 10. So e is, I believe, 2.71. So you do that, and it changes according to that. So this is a logarithmic axis now. You can do this with a y-axis as well. So this is how you change from a normal axis to a log axis. Okay. So I think everyone understands what to do now with these plots. This is something, the log axis is only for this part, not for the previous ones. Yeah, these are some questions. What is the slope of, okay, slope, right? So now you have this, and you should probably now, okay, you have your axes. I think you go to, what was it, page layout? No. Should be here, I believe. Okay. Hold on. Layout. Okay, let's see. Format. Nah. Okay, quick layout. Yeah, this is the one I want. So chart design is where you should go. And layout 9. This layout 9 here. I think I'm still sharing my screen, right? So
yeah, we can see you.
Okay, so layout 9 is what I want. That gives you the slope automatically. And I think everyone knows what this equation means. This is just of the form y is equal to mx plus b, where y is the y-axis, x is the x-axis, m is your slope, and the b is the vertical intercept. I think that is what we cover in the first lab in physics 1. So everyone is familiar with that equation. So this equation, you don't need to look at the r squared. That's not really what we want. Just this equation, y is something into x plus or minus something. So this something is your intercept, the vertical intercept, and 28.25 would be your slope. In this case, this is, I mean, these are just random numbers, so it doesn't make sense here. But yeah, this will be your slope. So you can find your slope this way using this quick layout and choosing layout 9. Okay, yeah, so semi-log plot, plot area of VS is R. Slope of, what is the slope of? Just, yeah, the grammar is a bit weird, but I think you understand what they're asking. Will that also be the best straight line? Yes, a slope is going to be a straight line. Slope can only be a straight line. So that is your linear fit, basically. So yeah, I think everyone understands what to do here. Are there any questions? I think this is just, the instructions are here. You just need to keep doing what they're saying.
I have a quick question.
Okay.
So last week you walked us through how you wanted the labs to look with the different sections and whatnot. And here it looks like it's just sort of question and answer where you just go through. So do you want us to do that lab thing from last week and then just answer these questions there, or just answer the questions right here in this file?
So you create a document and the purpose, the purpose is already given to you. So basically copy that. And after that, you have the apparatus. Well, the apparatus, there's no apparatus for this because it's a simulation. So you just say it's a simulation. Then you write the theory. So you need to talk about Coulomb's law. You just have the equation here, but you need to talk about what it means. Then you need to talk about Gauss's law because that is what you're using for the second part of the lab, and explain that a little bit. And then you write, okay, procedure, whatever you did, I place one electrical charge. Then you sketch whatever you get, and that comes in the analysis section. So you still need to have those different things here, but you can just, for example, that you can just copy this data table from here to your other Word file where you're making the lab report. And again, you can also copy these questions and answer them there. So again, no need to have this part because this is lab section 2. You can copy this to a different file and use it next week. But for now, we just want this part. So you need to have those sections, and that's important because those are part of the lab report. If you just answer these questions and just write the data in here, you probably are not getting even 50 points because most of the points are for theory, for procedure, and analysis. So if you don't do that, you're not getting many points.
Okay, thank you.
So all of these questions we put at the very end of the lab report, right after our conclusion and everything.
Yeah.
Okay.
Yeah, that's I think that is better. Or if you like, you can also do them in the analysis section. I mean, this is basically analysis. All these questions you will also answer in the analysis section. What type of relationship do you observe? So you're going to answer that in the analysis anyway. So you could just put them in the analysis section. Since this lab doesn't have those typical post-lab questions, which we'll have from the next lab. So there are no really post-lab questions. These are part of the lab itself. So you can just have them in the analysis section. That's not a problem.
Okay. And then one more question for whenever we have to take screenshots, do you want that with our data tables or like our graphs, or like where exactly do you want those sections?
So here, just take, for example, you have some electric field here. So you just, take a screenshot like this of your electric field, whatever it wants. So you have the parallel plate capacitors, just the parallel plates are there. So you can have them, just take a screenshot of those. Okay, that is what I did, and just put them on your lab report where you have the analysis for that part.
Okay.
Yeah.
So can we use screenshots for where it says sketching as well, or do we have to actually hand draw those?
Sketching, yeah, you can do both, whatever works for you. Sketching, yeah, if you're doing this online, I think is a better, screenshots are better, that's probably a better way. If you were doing this in person, obviously you have to do it with just hands. You have to draw them.
Okay, thank you.
Mm-hmm. Okay, any other questions? Stop sharing. Yeah, I think this is a pretty simple lab. Nothing much talk, but not very complex. Just follow instructions and write whatever data you get. Try to solve, I mean, the theory, right? So you know what to expect. So if you get some ridiculous numbers, try to think why. Don't just write them down. Try to think why and try to think, okay, am I doing something wrong? And you can also email me, okay, I'm getting these numbers, these doesn't make any sense, and we can talk. So don't just write down everything that you get on the first try, because and that might happen if you keep it for late. So try to attempt this lab as early as possible. And if you have problems, you can ask me. Equipment list is online. YouTube link for videos is online on Blackboard. Again, let me share my screen. So yeah, lab 1 is here. I don't like this interface. I'm sorry. This takes some getting used to. Course information. See how the syllabus, the calendar, sample lab report, the kind of grading, the grading that I do, the system that I use is here. Equipment list and the link is here. So that's, I think, everything. If I'm missing something, you can let me know. If I haven't uploaded something, but I think I have. Yeah. So I hope all of you have completed your test report. It's like a 5-minute thing. The instructions were there. So hopefully you've done that. If you haven't, so I think the deadline is today. It's not really for points, but just let me know that you can post in that PDF format that I want. So if you haven't, just take 5 minutes after the lab and do that. Lab 1 is due next week on Tuesday, 11:59 p.m. So you have 1 week and a few hours to complete this lab. And that will be the case for every lab.
On Blackboard, it says it's due September 28th.
Really, it does?
Yeah.
Okay, let me see. Oh yeah, that is weird. Okay, check now.
All right, now it says the 7th.
Okay, yeah. So yeah, that can happen sometimes. You just don't pay attention to those things. But yeah, if there are any mistakes like that, just let me know. But you know that for every lab you have 1 week, so that you know. So if there are any issues with dates, just let me know. Okay, if you guys don't have any question, that'll be all. I actually have to go for something. I have a seminar tomorrow. You might have seen the flyers around, so I need to go work on that a little bit. So yeah, that'll be all for today, and that'll be it. I will see you next week, and if you have any issues, let me know. Goodbye.